Caching is the single most impactful optimization in system design. It can turn a 150 millisecond database query into a 2 millisecond in-memory lookup. Here is how to use it correctly. Caching, Redis, CDN, and cache invalidation. High-level design, Day 4. Without caching, every request hits your database. That means every user action triggers a network round trip to your database server, a query execution, and a response back. For a typical PostgreSQL query, that is 100 to 200 milliseconds. Now imagine you have 10,000 users requesting the same product page. That is 10,000 identical database queries. With caching, the first request hits the database. The result is stored in an in-memory cache like Redis. The next 9,999 requests get the result from cache in about 2 milliseconds. That is 75 times faster. Caching is not optional in production. Every system you use daily, from Google to Netflix to Twitter, relies heavily on multiple layers of caching. In a production system, caching happens at multiple layers. Think of it as a hierarchy where each layer caches requests before they reach the next, slower layer. First is the browser cache. Your browser stores static assets like JavaScript, CSS, and images locally. Latency is 0 because the data never leaves your machine. Second is the CDN. Content delivery networks cache content at edge locations worldwide. When a user in India requests an image, it comes from a Mumbai edge server, not from your origin server in the US. Latency is about 10 milliseconds. Third is the application cache, typically Redis. This sits between your API server and your database. It caches frequently accessed data in memory. Latency is about 1 to 2 milliseconds. Fourth is the database itself, which is the origin of truth. Queries here take 100 to 200 milliseconds. The key insight is that each layer intercepts requests before they reach the slower layer below it. Redis is the most common application-level cache. There are two main patterns. Cache aside, also called lazy loading. When your application needs data, it first checks Redis. If the data is there, that is a cache hit. Return it immediately. If not, that is a cache miss. Query the database, store the result in Redis with a TTL, and return it. The next request for the same data gets a cache hit. This is the most common pattern because it only caches data that is actually requested. The second pattern is write through. Every time you write to the database, you also update the cache immediately. This means the cache is always in sync with the database. The trade-off is that writes are slower because you are writing to both database and cache. Use cache aside for read-heavy workloads. Use write through when data consistency is critical. Cache invalidation is famously the hardest problem in computer science. Phil Carlton said there are only two hard things in computer science: cache invalidation and naming things. The problem is simple. Your cache has data. Your database gets updated. Now the cache is stale. How do you fix it? 3 approaches. First, TTL expiry. Set a time to live on every cached item. After 5 minutes, the data automatically expires, and the next request fetches fresh data from the database. Simple, but the data can be stale for up to the TTL duration. Second, write through invalidation. Every time you write to the database, immediately update or delete the cached version. The cache is always fresh, but writes are slower. Third, event-driven invalidation. When the database changes, it fires an event through a message queue. Cache listeners receive the event and invalidate the affected keys. This is the best approach for distributed systems where multiple services share cache data. 3 cache pitfalls you must know for interviews. First, cache stampede. Imagine a popular key expires. Suddenly, 1,000 concurrent requests all see a cache miss and all query the database simultaneously. Your database gets crushed. The fix is a lock plus single fetch approach. Only one request fetches from the database. The rest wait for that request to populate the cache. Second, stale data. Your cache shows old data while the database has new data. Users see inconsistent state. The fix depends on your consistency requirements. Shorter TTLs for more freshness, event-driven invalidation for near real-time consistency. Third, memory pressure. If you cache everything, your Redis instance runs out of memory. the eviction policy kicks in and starts removing items randomly. The fix is to only cache hot data, set a maximum memory limit, and use an LRU eviction policy so least recently used items get evicted first. Here is your interview framework for caching. First, identify the hot path. Is the system read-heavy? If 80% or more of operations are reads, caching will have a huge impact. Second, choose the cache layer. CDN for static assets like images and JavaScript. Redis for dynamic data like user profiles and product listings. Browser cache for user-specific preferences. Third, choose the caching pattern. Cache aside for read-heavy workloads. Write through when data consistency matters. Fourth, address the invalidation strategy. TTL for simple cases. Event-driven for distributed systems. Fifth, handle edge cases. What happens during a cache stampede? What about cold start when the cache is empty? The pro tip is to mention cache invalidation before the interviewer asks. It shows you understand the real complexity, not just the happy path. 5 things to remember. Caching happens in layers: browser, CDN, Redis, database. Each catches requests before the next slower layer. Cache aside is the go-to pattern for read-heavy workloads. Cache invalidation is the hard part. Use TTL for simple cases, event-driven for distributed systems. Watch out for pitfalls like stampede, stale data, and memory pressure. And in interviews, always mention invalidation proactively to show you understand the trade-offs.